So I've been working on the electrical system for my race car, and I'm gonna show you what I've just been doing the last couple of days. And I've pretty much moved the whole system here to my workbench from my race car, because it's much easier to set up here than when mounted inside the car. And it's also winter still, so it's pretty cold in the garage. So onto the bench. Pretty much the whole electrical system is laid out here and on the floor, and that is to set up this new dash and have it working with the ECU and different CAN keypads and the transmission controller and the PMU. And here's the newest addition, these laser sensors that are going to be used for measuring ride height. And they are actually two different models, which I bought accidentally. One is an analog version, which gives an analog output signal, which is much easier to set up in the dash. And this is actually made for a sort of industrial CAN bus system, or something like that. But fortunately, it has a frequency output, and my dash can handle both analog and frequency inputs. So I'm going to show you guys how I set it up in the EMtron Display studio. So up here on the right, we actually have the ride height sensors set up, so you can see that they are measuring 90 millimeters and 135, and now I'm moving them up and down. And how I set it up is the analog here. You can go over to right at the rear, and I'm going to change this over later, but this is what I've been working on right now. So I've chosen the channel, which is the channel that's going to be displayed, and the channel I'm going to be working with inside the dash or the display studio. And I choose voltage channel because it gives out a voltage signal. So it's a 12 volt input, and it gives out voltage signal from about 0 volts to 10 volts. So, and I add range. So high 15 volt range, and I think it's voltage channel 5, 6, 7, 8 can handle 15 volts or display those values. And then I've set a calibration point, and I just chose 3. And then I took 1 volt. The sensor gives out a 1 volt signal at 50 millimeters, 5 volt at 165 millimeters, and 10 volts at 300 millimeters, and that's the range of the sensor. And I chose to compare that to the sensor. You can see it on the analog. You can see the analog volt 8 signal on the right. Changes when I go up and down. So I've compared it to the spec sheet and also what the measurement is on the display on the sensor itself. And that's proven accurate. So that's pretty much how you set up most analog sensors. But the frequency outputs or inputs is a bit more tricky. And especially because there's no real information in the manual yet on how this works. So I had to fiddle around a bit. So on frequency channel, I chose the ride height F. And then as a digital channel, I chose digital 3 frequency. and we can have a look at, and it shows 50 Hertz at the moment. I'm gonna move it up and down, the sensor, and you see that it changes. So it's comparable to the other sensor that they gave a volt signal. And then I went ahead and made a 3 calibration point table. So, and shows, then it shows 100 Hertz in 306 and 660. And that was pretty much just the numbers are a bit random, but it was the easiest way because to set those numbers up, because I had some issues with adding decimals here for some reason. So 100 Hertz at 35 millimeters, 306 Hertz at 150, and 660 Hertz at 300 millimeters, and that worked. And then of course we want to check this to make sure that it's you can actually see at the graph how they are working. And you can't see that in Display Studio, what I've found. So what I did is I went ahead and did a log file. So what you have to do is you have to go to this window here, download the log file, which I've already done. And then you have to open up EMvision. And here we have the graph of the right-hand sensors. So I'm gonna press play here. And this is me moving the 2 sensors up and down. And they're not perfect parallel because I didn't hold the sensors perfectly. But it gives a rough indication of that it works pretty good actually. So honestly, do I really need these sensors? Probably not. I'm a bit nerdy when it comes to electronics, and I really love to fiddle around with these more advanced functions. So I'm really happy with this, and even though it's a bit unnecessary, it's going to be a good addition to evaluate my driving when it comes to that, hopefully later on this year. So until next time, bye.